No.
Good evening, everyone.
Good evening, ma'am.
Good evening.
What will you discuss today, ma'am?
Yeah, today we will be doing week 5.
Is this theory session? Week 5.
Sorry?
Is this theory session? Theory session.
Yeah, it's a
Week
theory
5.
session. Yeah.
Okay.
Can I ask the graded assignment 4 doubts if I wish?
Week 4.
Yes, ma'am. Ma'am, there's actually just one question I have to ask in the graded assignment.
Okay, what's the question?
Ma'am, let me just tell you the question number.
Has anyone seen week 5 content?
Yes,
ma'am.
So you were able to understand it?
I have some problems in this thing.
Okay, other than Alok, anyone else? Has anyone seen?
Concepts are easy, ma'am, but coming to questions of practice,
Mm-hmm. Question that you have given to me, it's like 2 minus 0.0.
Ma'am, it's question 6 of the graded assignment.
So actually, like it's minus 0.03. Basically, it's like closer to 0, right?
Yes, ma'am.
Yeah. So it would be like there is no relationship between them.
Okay. Actually, I thought it's negative and there's just some value. It's not exactly 0, so the answer should be negative and weak.
Oh, no. We see it's like 0.03. Basically, it's 0 only, right?
Mm-hmm.
Yeah. So that's why there
It's
is
not
no-
exactly 0, so we can't say there's a direct absence of linear relationship.
Sorry. What?
Ma'am, since the coefficient is not exactly 0, I don't think we can say that there is an entire absence of the linear relationship.
See, there is like minute, like it's a decimal thing only, and it's like 0.03. Like it's very minute.
Okay.
So we can say that like there is no linear relationship between them.
Okay.
Yeah.
Thank you, ma'am.
Yeah. Okay. So shall we continue with week 5 then? Shall we start with that?
yes, ma'am.
Excuse me, ma'am.
Everyone?
Yes, ma'am.
Okay. So in week 5, we are basically the main topic is permutation. Okay. So before that, we have some of the topics. So there are two, like first of all, we will be studying about the basic principle of counting. Alok, you have any doubts?
Ma'am, when you discuss theory about the week 5, then please take some example because I completed the week 5 content but not able to solve question very comfortably. Please take
Can
some
you
example.
repeat once again?
Ma'am, please take some examples with every theory, please.
Yeah, sure. Okay. So, yeah. So the first thing is we are going to understand the basic principle of counting. So in basic principle of counting, we have two basic principles. So the first one is the addition rule of counting. Okay. So what do you mean by addition rule? If let's say I have an I have an action A, okay, which is occurring in n different ways, and I have another action B, which is occurring in n two different ways. Okay. So if I have to find out the total number of occurrence of the action A or B, okay, if I have to count the total number of occurrence of the actions A or B, it would be equal to n1 plus n2. Okay, so this is addition rule of count. So let's take an example. Okay, so let's say you're going to a market. Okay, so like you have to make, there are 4 shirts. Okay, there are 4 different colors of shirts. Let's say we have yellow, we have blue, we have green, and we have red. Okay, these are 4 types of shirts. Okay, then we have 3 types of pants, which are in like color like black, blue, and brown. Fine. These are the 3 types of pants you have. Okay, so the thing is, like you can only buy one. Like if you're going to a market, you have to buy only one thing from these set of things. Okay, so if you see here, this is first action. Okay, this is my first action. So A is considered to be the action like choosing a shirt. Okay, and the second action is, this one is my B. This is the second action, that is choosing from a cloth from a pant. Okay, so I have to calculate A or B. That means that I have to choose a shirt or a pant. You getting my point?
Yes, ma'am.
Yeah. So okay, so my A, this action is going like how many ways I can choose a shirt? I can choose a shirt 4 times, like 4 ways. Like I can choose either yellow, either blue, either green, or either red, right? So I have 4 choices, right? So my N1 is 4. Similarly, for the B action, how many different ways I can choose the pants? So what is my N2 here? It would be, anyone?
3.
It would be 3. Correct. Because I have 3 choices. Like I can choose black, either black, blue, or brown. Got my point? So I have got N1, I have got N2. Now I have to calculate A or B. That means choosing a shirt or a pant. So it would be equal to N1 plus N2, which is equal to 4 plus 3, which is 7. So in total, we have 7 choices available for selecting a cloth. Got my point?
Yes.
Everyone? Okay. Yeah. Now let's say, these are the choices. Okay. Now you have to calculate, like you are choosing 2 clothes at a time. Okay. 1 shirt and 1 pant. These are the 2 choices that you are going to select. Okay. So how many choices you would be having? Like, so it would be like my, with yellow shirt, I would be having 3 choices of pants, right? It would be black. Okay. It would be blue. It would be brown. Correct? Similarly, for all the 4 colors like blue, green, and red, I would be having 4 choices, 3 choices for each of the shirts. Correct?
Yes, ma'am.
Okay. So in total, how many choices I have to select a pant and a shirt? So it would be equal to 3 plus 3 plus 3 plus 3. In total, it would be equal to 12 ways.
Yes, ma'am.
Correct?
Yes,
Okay.
ma'am.
Yeah. So this is my addition rule of counting. Okay, so if I have one action A, one action B, in which my action A is in n different ways, my action B is in n two different ways. So if I have to calculate the total number of occurrence of choices of choosing A or B, it would be equal to n1 plus n2. Got it?
Yes,
Yes,
ma'am.
sir.
Okay. Now, the second rule of counting is the multiplication rule of counting. Okay. So what is addition rule of counting? If I say, same, I have an action A, which is occurring in n different ways. I have action B, which is occurring in n2 different ways. Now, I have to calculate the total number of occurrence of the action A and B together. Okay. Then that would be n1 into n2. Okay. Say, for example, I have to create a 6-digit alphanumeric password. Okay, so there are three spaces. It's 6-digit, right? So 1, 2, 3, 4, 5, and 6. Okay, so I have to make a 6-digit alphanumeric password. Okay, so the thing is, there are some conditions. The condition is like the first two should be the alphabets. Okay, and the remaining 4 should be the numbers. Fine.
Yes,
Okay.
ma'am. Yes, ma'am.
Yeah. Now I have to like so what are the total number of ways I can choose a password? So for the first letter, it should be alphabets. In total, we know that how many alphabets are there?
26.
26, right? So in the first place, I have 26 choices, correct?
Yes, ma'am.
Yeah. Now for the second thing, if the condition is I am repeating the like repetition is allowed. So that's if I if I have a password like AA, so I can repeat that alphabet again. So that means there is a repetition allowed here. Okay. Now, so so the first one is I have 26 choices to select one alphabet. Then for the second place, how many choices do I have?
26, because repetition is allowed.
Yeah, repetition is allowed. Okay. Now, in the third place, it should be a number, right? So in total, how many numbers are there?
10, from 0
10,
to
right?
9.
So how many choices I have for the third digit? It would be 10,
10, yeah.
right? Similarly, 10, 10, and 10, correct?
Yes, ma'am.
Yeah. So this is basically a multiplication. So in total, how many ways it would be? 26 into 26 into 10 into 10 into 10 and into 10, correct? These are my ways.
Yes, ma'am.
Yeah. So into so some value would be there. It would be like 67 lakhs, 60,000. These are the number of ways of which I can create a password in which the first two letters would be alphabet and the last 4 digits would be my numbers. And here the repetition is allowed. Got my point?
Yes, ma'am.
Yes, ma'am.
Okay. Now, if my condition is that my repetition, I'm not allowing the repetition. Okay, there is no repetition here. So what are my so just tell me what are the choices do I have for the first digit then?
26,
26,
26.
25,
25,
Okay.
10,
10,
Mm,
9,
9, 8, 7.
8, 7.
good. So it would be the total number of like the choices would be 26 into 25 into 10 into 9 into 8 into 7. Got my point?
Yes,
So
ma'am.
it would be 32,76,000. Fine. So these are my total number of ways by which I can create a password. Got my point, everyone? So this is the multiplication rule of counting. Everyone got it?
Yes, ma'am.
Yes, ma'am.
Okay. So can I proceed further now?
Sure.
Okay. Now the second thing comes is factorials. Okay. So what is a factorial? So let's say, for example, there are 8 athletes. Okay. There are 8 athletes who take part in a 100-meter race. Okay. Now we have to calculate what are the possible ways the athletes can finish the race. Okay, like we have to calculate that who comes first, who comes second, third, and fourth. So in total, we have 8 athletes, right? So we are having 8 places: first place, second place, third, fourth, fifth, sixth, seventh, and 8 places. Correct? So for the first place, how many choices do I have? From the 8 athletes, I have 8 choices.
8 choices, yes.
Yeah, correct. Now for the second, like from the 8 choices, like the first person has got the first place, right? One person has got the, from the 8 people, one of them has got the first place. So for the second place, how many choices do I have?
7.
7,
7, right? Okay. Then for the third,
6, 5,
6,
4, 2,
6,
1.
5,
6,
4,
4,
3,
3,
2,
2, 3, 2,
3,
1.
2, 1.
yeah. So these are my possible ways. Okay. Like these are my possible ways that the athlete can finish a race. So in total, it would be 40,320, right? So what do you mean by factorial? Factorial is like the product of first n positive integer. Okay, so this is known as factorial. Okay, and it is represented as like if I have 8 athletes, right? That means these are the number of integers. So in total, I would be like factorial, it is represented as n
8
factorial.
factorial.
Okay, so if here I am having 8, so my value of n is 8, so it would be 8 factorial, and I can write it as 8 into 7
7
into
into
6
6.
into 5, like that. Okay, so in general expression, we can say n factorial is written as n into n minus 1 into
Into
n minus 2, like that, till 1. Got it? What do you mean by
Yes, ma'am.
factorial? Right?
Yes,
Yes, ma'am.
And yeah, and the
Yes,
thing is,
ma'am.
0 factorial is equal to 1. Okay. Okay, now
1 factorial also equal to 1. Right?
yeah, 1 factorial is equal to 1. Okay, so 0 factorial is 1 and 1 factorial is also equal to 1. Okay, now so okay, what is the value of 5 factorial? How can I write 5 factorial? It would be equal to
5 into
5
4 into
Yes.
3 into 2, 1
into 2
into
into
1.
1.
2 into 1, which is
120. No.
to 20. Okay, now just tell me if I can write 5 factorial as 5 into 4 factorial.
Yes, ma'am.
Yes, ma'am.
Sure.
Yes, ma'am.
Yeah, I can also write it
Yes.
as 5 into 4 into 3 factorial.
3
Yes,
factorial, yeah.
ma'am.
Yeah,
Correct?
definitely.
So in
Yes,
general,
ma'am.
we can say that for I less than equal to n, we have n factorial is equal to n into n minus 1 into n minus I factorial. Okay, so here, let's say, so in this example, I have n is equals to 5, right? So my values of I would be equal to 1, 2, 3, 4, and 5.
Yes, ma'am.
Yeah, so I can write it as 5 factorial can be written as 5 into, let's say my I value is 1. So it would be equal to 4 factorial,
Yes, ma'am.
Yes,
correct?
ma'am.
Similarly, if my I, like here my I was 1. Now my I is equals to 2. So it would be 5 into 4 into 3 factorial.
Yes, ma'am.
Okay. Similarly, my I is 3. So it would be equal to 5 into
5
4
into
into
4
3.
into
Into
2
2.
factorial.
Got my point?
Yes, ma'am.
Okay. Now we are going to simplify some of the expressions. Okay. So let's say I have a value 6 factorial divided by 3 factorial. Okay. So how will I solve this? Okay. Now
6 into 5.
6 into 5
5
into
factorial.
Into 3
Wait,
factorial divided by 3
yeah,
factorial, and
factorial.
these
We can
3 will
cancel.
be cancel out.
yeah. So I would be having 6 into 5 into 4, which is equals to 120.
120.
Fine. Similarly,
Yeah.
if I have another expression as 6 factorial into 5 factorial divided by 3 factorial into 4 factorial. It would be equal to
into 5, 4 factorial and 5 into 4 into 3 factorial, 3 and 4 would be like
Yeah,
Six
so I can
into
write it
5 into
5 into 4
4
into 3
into
factorial
3 factorial.
by
5
3
5
factorial,
into
4
5
factorial divided by
into 4 factorial. 4 factorial divided.
yeah, this will get cancelled. So in total, I would be having 6 into 5 into 4 into 5 into 4, correct? And this is equal to 600.
600.
Got it?
Yes,
Okay.
ma'am.
The last one is like I have to convert this expression as 25 into 24 into 23 in terms of factorial. Okay. So how can I convert this? Anyone?
25 into 24 into 23 factorial.
See, I have to convert this
5
into
by
a factorial.
22 factorial.
Yeah. So I would be multiplying and dividing with same number. So see, the numerator, like it's 25 into 24. So I can write it as 25 factorial. I have to write this as a 25 factorial, correct? So if I have to write this as a 25 factorial, I should have the numbers like after 23 also like 22, 21, 20 like that till 1, correct? These number are missing for it to be happen as 25 factorial, correct?
Yes, ma'am.
Yeah. So if I have to convert this into a 24 factorial, I have to multiply 22 into 21 and also divided by 22 into 21 into 20 till 1. Got it? So now this whole is equal to 25 factorial.
Yes, ma'am.
And
Upon 22 factorial.
it would be 22.
22 factorial.
Yeah. Everybody got it? Everyone?
Yes, ma'am.
Okay. So this was the factorial. Now comes the main topic, which is permutation. Okay. So in permutation, we have two conditions in which my repetition is allowed and my repetition is not allowed. Okay. So I'm taking the first condition in which my repetition is not allowed. Okay. So what is a permutation? Permutation is a ordered arrangement. Okay. Ordered arrangement of all or sum of n objects. Okay. So this is my permutation, which is the ordered arrangement of all or sum of n objects. Okay, so these are the main, these three are the main points. It should be having order, and in permutation, we are arranging n objects. Okay, so this is permutation. In this, we are not allowing repetition. Okay, so let's take, for example, I have three values, A, B, and C. Okay, so I have to arrange in which I am taking all at a time. Okay, so here my n is 3. In total, I have 3 values, right? So in total, my n value is 3, correct?
Yes, ma'am.
Okay. Now, I am taking all at a time, right? So, so this would be equal to, let's say, this is n. So my r is 3, correct? Okay. So before that, the permutation, it's denoted as NPR. Okay. So my n is the number of objects and r is like whether we are taking all the objects or some of the objects.
All the objects.
So here my all at a time, I'm taking all at a time. So my value of R would be equal to 3.
Yes, ma'am.
Yes.
Yeah. So
Yes,
now
ma'am.
with the I have to arrange these values, taking all at a time. So it would be equal to 3P3,
Yes, ma'am.
right? And this would be equal to
3 factorial upon 3 minus 5.
yeah. So basically this formula is equal to n factorial divided by n minus r factorial, right? So this would be equal to 3 factorial divided by 3 minus 3 factorial. So this would be
Yes.
equal to 3 factorial divided by 0 factorial, and 0 factorial is 1. So it would be equal to 3 factorial only.
Yes, ma'am.
Yes, ma'am.
Correct. Similarly, I'm having second condition in which I have 3 values only, A, B, C. In this, I'm taking 2 at a time. So now tell me what is my n here?
3.
N
N
is
is
3.
And
R
R
is
is 2.
R is
2.
2.
So it would be 3P2, which is equal to 3
3
factorial
factorial divided by 3 minus 2 factorial.
factorial. This is 3 factorial divided by 1 factorial, which is equal to 3 factorial only. Yeah.
Yes, ma'am.
Yes, ma'am.
Okay. Now, if I have 4 values, okay, and in this I'm taking 2 at a time. Now tell me what is the value of n here?
4.
4.
4, ma'am.
N is 4, R
And
is
R is
2.
2. So it would be 4P2
4P2.
to 4 factorial
4
divided.
factorial divided by 4 minus 2 factorial.
Okay. Here,
2 factorial.
2 factorial. Then
4 into 3 into 2 factorial.
good. Divided by 2 factorial.
2 factorial.
Factorial
Then
cancel.
cut.
Equal
12.
to 12. Everybody got it?
yes,
So
ma'am.
this is my permutation. So my permutation formula is, so it is denoted as NPR, in which it is equals to n factorial divided by n minus r factorial. Okay. And we have some special cases in which NP0, it would be equal to n factorial divided by n minus 0 factorial, which is equals to n factorial divided by n, which is equals to 1. So
Okay.
my value of NP0 would be equal to 1. Okay, that means there is only one ordered arrangement of 0 objects.
Ma'am, could you explain this point a bit with an example? How could we choose 0 objects from n objects?
0 objects in the sense, like actually we are not choosing any objects. That's the case. So if we are not choosing anything, so we have only one ordered arrangement.
Like, how is that one coming then, ma'am? If we are not even arranging anything.
Okay. Okay, just give me some time. I'll check. Right now, I'm not having any example right now. So just
Okay,
give me some time. Okay.
if it isn't now, if you can't make it now, we'll talk it later. We'll discuss it about it
Yeah,
later.
yeah, sure. Yeah. Yeah, just give after at the end, just give me some
Yes,
time.
ma'am. Yes, ma'am. No
Okay.
problem.
Now,
Please.
then we have, yeah, NP0, then we have NP1. Okay. That means we are choosing one object from the n objects. So it would be, that means we are arranging one object from the n object. So it would be n factorial divided by n minus 1 factorial. This would be equal to
N.
n. Correct?
Yes, ma'am.
Yeah. Okay. So that means we have n ways of choosing one object from the n objects. Okay. Now the third point is npn.
NPN.
Okay. So it would be n factorial divided by n minus n factorial, which is equals to n factorial, right?
Yes, ma'am.
Yeah.
Yes,
So
ma'am.
yeah. So that means that we can arrange n distinct objects in n factorial ways. Got my point?
Yes, ma'am.
Okay. So let's say I have an example here. We have to we have to arrange or make 4-digit number. Okay. Using numbers like 1, 2, 3, 4, and 5. And here repetition is not allowed. Okay. So what are the number of ways that 4-digit number can be formed using these numbers? Can anyone tell me?
Yes,
Is
ma'am.
repetition
First,
allowed,
maybe
ma'am?
there are 5 possibilities.
It would be 5 factorial.
Yes, ma'am.
Yes, ma'am. Yes.
If repetition is
Like
not
in
allowed, it would be 5 factorial.
5 factorial. So it would be equal to 120. Correct. Now the thing is, like, how many of them will be even?
If they end with 2 or 4, it will be even, ma'am.
Yeah, correct. So like I have 4 digits, right? 1, 2, 3, 4.
Also
So
zero, ma'am. Zero way.
no, we have to select from these numbers, right? So there is no zero. So in total, we have 2 even numbers here, 2 and 4. So if
Okay,
in my
ma'am.
digit number, if my last would be 2 or it would be 4, right?
4.
Then it would be considered as an even number, correct?
Yes, ma'am.
Yeah. So let's say for this, like how many number of ways I can arrange this? So the last one is like I have like
3.
permanently, like yeah, it's permanent. Like 2 is there. So in total, I have how many choices? From 1, 3, and 4. But like I have from 4 digits, I have to arrange these 3 numbers from 3 numbers, correct? So it would be 4
Yes.
into 3 into 2.
Yes, ma'am.
Similarly for this also, 4 into 3 into 2.
Yes, ma'am. Twice of 4 factorial, which is 48 ways.
Yeah. So basically this would be equal to 4 into 3 into 2, which is 24. Similarly, this is 4 into 3 into 2, which is 24. So in total, we would be having 24 plus 24, which is 48. Correct?
Yes,
Okay,
ma'am.
ma'am.
Yeah. So
Hello.
there are,
Sorry.
sorry.
Hello. Hello, ma'am. Sorry to bother you. Ma'am, I have a doubt in week 4 in practice assignment. Can you explain?
Yeah. Like after completing this, I would be explaining it. Fine.
And
Okay,
please
ma'am.
explain again this. Please explain again.
This question.
Yes, ma'am. This example. This example.
The second one, this even one.
Yes, ma'am.
Okay. See, I have to make 4-digit number using these 5 digits. Fine. Now the condition is I have to calculate how many numbers are even. Okay, how many of these would be an even number? Okay. So for that to be even, my last digit should be 2 or 4. Correct?
Yes, ma'am.
Yeah. Okay. So let's say I have like this is my first case. Okay, and this is my second case. So in the first case, I'm having a permanent place for 2. Okay, this place is already filled with 2. So remaining 3 digits I have to fill with these 4 digits, right? Here we are not considering repetition, right? So 2 is already placed here. So from like if you remove 2, we have 4 choices: 1, 3, 4, 5. So from these 4 numbers, we have to arrange 3 places.
Ma'am, got it, ma'am. Got it. Got it, ma'am. Thank you
Got
so
it?
much.
Yeah.
Yeah.
Okay. Now the second thing is if repetition is allowed. Okay. So if my repetition is allowed, so let's say the number of possible permutation of R objects, okay, from a collection of n distinct objects, okay, when repetition is allowed is given by the formula n raised to the power R. That means n into n till R. So it is multiplied R times. So let's say, for example, I have uh, A, B, and C. These are three values. Okay. Now, what are the possible arrangements taking two at a time? In this, my repetition is allowed. Okay. So basically, what is the value of n here?
3.
3. And my value of R is
2.
2.
2.
2, ma'am.
So this will be equal to 3 raised to the power 2, right?
Yes,
Which is equals
yes,
to
ma'am.
9. Okay.
9.
So if you like, you can also take a like I have three values, right? So I have to take two at a time and I can repeat it. So what are the what are the values that I can have? Like it would be AA, I would be having AB, I would be having AC, right? Similarly, I would be having BB, BA, BC, right? Like that. So I would be having nine possible ways of arrangement. Okay. So this is my, so here my repetition is allowed. So if I'm having repetition, then the number of possible arrangements for R objects from the n distinct object, it would be equal to n raised to the power R. Got my point?
Yes,
Ma'am, I'm having a doubt.
Okay.
It's a question, like true or false. Like, sorry, if there are six questions, like six boxes, which we have to answer them as true or false.
Hmm.
I'm having doubt which is N and which is R from there over there.
This
Like,
is from activity question.
yeah, ma'am. Yeah,
ma'am.
one of the activity question only.
Yeah. Okay. So let's see.
I have also same type of thought, ma'am. But in the last
Just
of
a
it.
second. I think it's activity 3, right?
I don't remember actually.
Yes,
But
ma'am.
Yeah. Okay. Let me see. Okay. It is, in how many ways can a test paper of 6 questions be attempted? Okay. In total, we have 6 questions, right?
yes, ma'am.
So it is saying how many ways that it can be attempted. Okay. Being each question being of true and false type. Okay. So I have two conditions here. Like it is asking about attempting the question. So I have three conditions here. Okay. The first condition is I would be writing it as true, or I would be writing it as false, or I would not be attempting the question.
Yes, ma'am.
Yeah. So for one question, I'm having three choices.
Yes, ma'am.
Got my point? So what will it be?
Conventional method, like 3 power 6 I'm getting, like if we do it as manually. If we go through the formula, since there is a restriction that R can't be greater than n, right?
Yeah, correct.
But here we are doing 3 power 6, where R is 6 and n is 3. And I'm confused, why is it like that? Like I can understand through the normal where we can, like in a normal Desi method sort of method, choosing, we have three options for each question, so 3 power 6. But through the formula, I'm confused now. Why is it like that?
So you can consider it as okay. So you can consider, so basically the main point is R is less than equal to N. Correct. So you can consider it as like for true, I am having 6 questions. For false, I am having 6 questions. And for not attempting also, I'm having 6 questions, right?
Yes, ma'am.
So So you can consider it like that, or like, so the first question I'm having three choices. Similarly, for the second question, I'm having three choices. For the third question, I'm having, so till six, I'm having three choices here, right? So my three is getting repeated six times,
Yes, ma'am.
right? So it can be written as 3 raised to the power 6, like that.
Yes, ma'am. I agree. Yeah. Okay.
You're asking about with
Formula,
regard.
ma'am. How can we solve this question through formula?
No, ma'am. My question was, since the condition is R it should be less than or equal to N. Here, we are taking 3 power 6. Uh, how could here R is 6 and N is 3, right? That's what my doubt is. But I understood the method, how to do like such
Okay, yeah,
questions.
that's the point. Okay.
I guess this is some sort of exception case. I feel, yeah.
Okay. Okay, let me think about it actually. Okay, we will come back to this question again.
Yes, ma'am.
Okay,
Yeah, yeah. Let's move forward.
let's move forward now. Okay then. So, okay, so everybody, like, you're able to solve this question, right? Everybody understood this question, how we solved it?
Yes, ma'am. I
Yes, ma'am.
solved this question, an activity question also, but I have doubt how can I solve this question through formula method, because this is the theoretical method.
Yeah, we will come back to this question again. Yeah,
Sure,
just,
ma'am.
yeah, give me some few minutes. Yeah, okay. Okay, so so in summary, we can say that for permutation, if my repetition is allowed, so my value would be NPR, which is equals to n factorial divided by n minus r factorial, correct? And if I'm not, sorry, this is if repetition is not allowed, okay? And if I'm allowing the repetition, it would be equal to n raised to the power r, correct?
Yes, ma'am.
Yes, ma'am.
Yeah. I think here there is no condition as r should be less than or equal to n. Yes. Yeah. Yes. See. Okay. So till here, it's fine for everyone.
Yes.
Yes, ma'am.
Okay. Now, okay. So let's suppose I have a 4-digit value. Okay. So it is DATA. Okay. There is a word data in which I have to rearrange this letter. Okay. So how many ways it can be done? Okay. So my this is A1 and A2. So I can arrange it as DA1, DA2, or DA2, DA1, right? Or it can be as A1, D, A2, T, or A2, D, A1, T, like that. I can have many choices, right? I can have many ways of rearranging these letters, correct? That means how many ways I can arrange these letters, it would be equal to 4 factorial,
Yes, ma'am.
correct? That means there are 24 ways,
Yes.
correct? Now, here, my A1, this is the condition in which my A1 and A2 is distinct. Okay. Now I'm considering that my A1, like my this A and this A are not distinct. That means my A1 and A2 are both equal to A only. Okay. So in total, that means like these two values and these two values would be same.
How?
See, this is the condition in which I'm considering that my A, the first A and the second A are distinct. The two A's are distinct to each other. Then I have 24 possible ways of rearranging the letters, correct?
Correct.
Yeah. Now I'm considering that my A1, the first A and the second A, though both are equal, both are same. They are not distinct. They are same. They're equal to A only.
Yes, ma'am, got it.
Got it? So in that case, my these two would be same and my these two would be same.
Yes,
Similarly,
ma'am.
Yes,
I
ma'am.
would be having similarly different condition in which I would be having two same, correct?
Correct, ma'am.
The number of possible ways would be equal to
24 by 2.
24 by 2, which is
Yes, ma'am.
equals to 12,
12.
Mm.
correct? So if we go through the formula, if I'm having so the number of permutation of n objects when p of them are of one kind. Okay, like here my p is like a, so my a is of one kind. Okay, and the rest of them are distinct. Then the permutation would be equal to so the number of ways would be permutation formula would be equal to n factorial divided by p factorial. Okay, so if we see here, so I have to arrange this data, right? That is DATA. So here my value of n would be equal to
4.
how many objects I have? 4, correct? Now, what is my p? Yeah, the
2.
values which are of one kind, that is 2.
2.
2, ma'am.
So it would be equal to n factorial divided by p factorial. That means 4 factorial divided by 2 factorial.
Factorial.
Yeah, and this is equal to 4 into
4
3
into 3 into
factorial.
2 factorial divided by 2 factorial.
Yeah,
12. 12, ma'am.
so it would be equal to 12. Correct?
Correct.
Yeah. Similarly, if I'm having a word,
Madam. Malayalam.
you can say, yeah, let's take another one. This one. So what is the value of n here?
5.
It is 5. And what is the value? Like, so how many different kinds like are of one kind? So I'm having a of one kind, correct? So that is my
Yes.
p1 would be equal to 2. And
Mm.
there is another one which is of one kind, which is m. I'm denoting it as p2, which is equals to 2 also, right? So the value, the number of arrangements would be equal to 5 factorial divided by
Divided by 2
5
factorial.
factorial into 2 factorial.
yeah. So it would be equal to 5 into 4 into 3 into
4
2,
into 3 into 2 factorial.
2 factorial into 2, like I'm
fact-
opening, so it would be equal to 2 into 1, correct? So this 2 factorial will get cancelled. So in total, it would be 5. This 2 would
2,
be
2 into
this. So in
30.
total, it would be 30. Got it? So this case, like in general, we can say that if I'm having n objects, right? N objects, and like P1 is of one kind and P2 is of two, like second kind. Similarly, if I'm having K number of kinds, okay? So the number of permutation would be equal to n factorial divided by P1 factorial into P2 factorial till Pk factorial. Got it?
Yes, ma'am.
Everyone?
Yes, ma'am.
Now I'm having like I have to arrange like let's say I have to arrange 4 people A, B, C, and D in a round table. Okay. Like earlier we used to arrange it in a row. Linearly we used to arrange it. So if we are arranging it linearly, I would be having 4 factorial ways, right? But now I am arranging it in a round table. Okay. So in this, my permutation would be different, right? So let's say I'm having a round table here. So I'm having 4. So I have to arrange these 4 people. So one person would be here, one person would be here, one person would be here, one person would be here. So let's suppose that one person A is here, B is here, C is here, D is here. Similarly, I can arrange. So I can say that, let's say my A is here, B is here, C is here, D is here. So if you see here, these they are same only, correct? But if we in linear, I would be having choices I would be having A, B, C, D. Here it is B, C, D, A. So I have different choices linearly if we see. But in round table, in a in a round table in a circular motion, we see that these two values are same only, right? So in that case, my permutation, what would be my permutation according to in a round table? So I'm considering one like my clockwise and anti-clockwise are different. In this, we have 2 different conditions in which clockwise and anti-clockwise are different. And the second is clockwise and anti-clockwise are not different. They are same. Okay. So what would be my permutation of arranging these 4 people in a circular round table? Okay. So let's say, so these were the 4 people, A, B, C, D. Okay. So linearly, if I'm arranging this, so I would be having different conditions. It would be A, B, C, D, then it would be A, B, B, C, then it would be A, C, B, D, it would be A, C, D, B, right? Then I would be having A, B, B, C, A, B, C, B. So there are in total 6 ways, right? And if I'm having if I'm taking A as a first, I'm keeping the first place constant with A. So I'm having 6 ways. Similarly, if I'm taking B as a constant, the first one should be the B only. So what are the cases I would be having? B, A, C, D, then B, A, D, C, then B, C, A, D, B, C, D, A, B, D, C, A, and B, D, A, C. So into here also I'm having 6 ways. Okay. So if I'm arranging this, okay, I'm considering this is A, B, C, D. I'm taking one. Okay, this one. Now I'm taking another one, which is B, C, D, A. Similarly, C, B, A, B, then D, A, B, and C. So if you see here, all these values, first, second, third, and fourth, these are all same, right? Are you getting my point?
Yes, ma'am.
Yes, ma'am.
Yeah. Yeah. So these are all same. So how will I calculate the arrangement? So the way is, I will consider the first one, I would be keeping it permanent. So let's say A is permanent here. Now the 3 would be different, the 3 places, right? So it would be like B, C, D, or what else? C, D, B, or it would be A, D, B, C, then A, D, C, B, A, B, D, C, A, C, B, D. So these are the possible arrangements, right? So here I have kept A as permanent, right? So the other three will get changed. They would be arranged, right? So in total, I would be having, so these three places can be arranged in 3 factorial ways.
Yes, ma'am.
Everyone,
Yes, ma'am.
right? So let's say I'm considering my first position, I'm fixing the first position with A. So my rest of the 3 position would be, I would be arranging them with 3 values B, C, D. So in total, I would be the number of arrangements would be 3 factorial, which is equal to 6 ways.
Yes, ma'am.
So
Yes,
there
ma'am.
are, right? So if you see here, I have 6 possible ways: A, B, C, D, A, C, D, B, A, D, B, C, A, D, C. Like these are my possible 6 ways how in which I can arrange the 4 people in a round table, right?
Right, ma'am.
Yeah. So in general, if I'm saying like I have to arrange n objects in a circle in which I'm considering my anti-clockwise and clockwise direction are different. So it would be equal to n minus 1 factorial. So in this case, my like see my here in this case my n is equals to 4.
Yes, ma'am.
Everyone?
I have a little doubt.
Yeah, what's your doubt?
Ma'am, how can we consider the clockwise and anti-clockwise are different or same? Please explain.
Okay, see. Here it is A, B, C, D, right? This is my clockwise direction, correct?
Yes, ma'am.
Now, if you see here, this is A, B, C, D. This is anti-clockwise,
Yes, ma'am.
correct? This is going this direction and this is going this direction. So I am considering, so the values like I'm considering my anti-clockwise and clockwise are different. That means this value, this arrangement of values and this arrangement of values are different. Okay. And if I'm considering my clockwise and anti-clockwise are same, that means my, see, the values, they're sitting as A, B, C, D. Here also it is sitting as A, B, C, D, right? The thing is that they are going in clockwise direction and this is in anti-clockwise. So if I'm considering my clockwise and anti-clockwise are same, that means these 2 positions would be same. These 2 would be equal only.
Yes, ma'am. Got it. Got it. Thank you so much, ma'am.
Got it? Yeah. So the first thing is I'm considering my clockwise and anti-clockwise are different. Okay. So in total, I would be having 6 cases. And how will I count it? It would be n minus 1 factorial, correct? So according to this question, my value of n is equals to 4. There are 4 possible, there are 4 objects, right? 4 distinct objects, A, B, C, D. So my value of n would be?
3 factorial.
So yeah, so the value of n would be 4. So the possible arrangement would be n minus 1 factorial. That is equal to 3 factorial. Which
Yes,
is
ma'am.
equal to 6. Got it? So if there is a circular, like if there is a question asking about arranging the people in a round table, you would be fixing one place and then arranging the rest of the places. Got it? Okay. So this
Yes.
is the case when my clockwise and anti-clockwise were different. Now I'm considering they are same. Okay. That means these both are same. These both are equal and these both are equal. So it would be, so the formula would be n minus 1 factorial divided by 2. So it would be equal to 3 factorial divided by 2, which is equals to 3 only. Like
Yes,
in
ma'am.
general, yeah. So in
Mhm.
general, if you see these, like these both are same, these both are same, and this. So this would be equal to half of 6. Right?
Yes, ma'am.
Yeah. So that's the general formula. So if I'm considering my clockwise and anti-clockwise direction different, then it is n minus 1 factorial. If I'm considering it same, and we say that n minus 1 factorial divided by 2, it would be half of this. That's it. Till here, anyone having any doubts?
No, ma'am.
Ma'am,
No,
you're
ma'am.
saying ABCD in ABCD if two are equal, like AABC.
Two are equal.
Yeah, in the same ABCD, if two values are same. So it would be you are saying that AA and BC or AACD, anyone, any of the four groups.
No, here we are considering that all the objects are different. We are not considering same.
Ma'am, below formula, the same one, n minus 1 factorial divided by 2 for this
Yeah,
condition.
for this condition, yeah. See, here, this thing is A, B, C, D. And in this anti-clockwise direction, it is A, B, C, D only, right? So these both are same only. This is just in clockwise direction and this is just in anti-clockwise direction. So these both, the arrangement is same only. So here we're considering the clockwise direction and anti-clockwise same, right?
Right, ma'am.
Yeah, that's the thing.
I'm asking about what if the values are same of any of two elements? Like the
That-
previous one you told us.
Which one? This one?
Scroll down, ma'am. Yeah, ma'am. This one.
No, no. That's a different condition then.
Okay.
Till here, anybody having any doubts?
No, ma'am.
Okay, so shall we proceed now further?
Yes.
Okay, everyone. Now, the thing is, now we will be solving some of the expression in for n. Like we would be finding out the value of n. So if I have some like one expression like np4 equals to 20 into np2. Okay, this is my expression. So I have to solve for n. That means I have to find out the value. How would I be solving it? So this one I can expand it. It would be equal to n factorial divided by n minus 4 factorial. Correct? Now, this can be written as 20 into n factorial divided by n minus 2 factorial. Everyone? Is it clear till here?
Yes, ma'am.
Yeah. Okay. Now, if you see here, this n factorial and n factorial will get cancelled. Okay. So I would be having n minus 4 factorial. Okay. And I'm taking this side. So it would be 1 into n minus 2 factorial, which is equals to 20. Is this step clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now, which part I would be expanding so that this would get cancelled?
N minus 4 factorial.
Correct. So n minus 2 factorial will remain as it is. This would be n minus
n
4
minus 4,
into n minus
3,
3.
3, n minus 2, n minus 1. Yeah, n minus 2 factorial itself.
Just a second. No. Just tell me whether this is correct. Just think about it. Is this step correct? Okay. So the n factorial it is written as n into n minus 1 into n minus 2 like that, right?
Right, ma'am.
Yeah. So now my n minus 4 factorial, it can be written as n minus 4 into n minus 4 minus 1.
Yes, ma'am.
And
Correct.
right now,
So this would be equal to n into n minus 4 into n minus 5 factorial.
Yes, ma'am.
So, and now my n minus 2 factorial, it can be written as n minus 2 into n minus 2 minus 1, which would be equal to n minus 2 into n minus 3 factorial.
Yes.
Right, ma'am.
So now, which should I expand?
Uh,
The, the numerator part, right?
yes, ma'am.
Yeah. So this would be n minus 2 into n minus 3 into n minus 4 factorial divided by n minus 4 factorial, which is equals to 20.
Hmm.
Correct? Now this would
Correct.
be cancelled. So the value would be n minus 2 into n minus 3 equals to 20.
20.
Right? Now we will open the brackets. So this would be equal to n square minus 3n minus 2n plus
6.
6, right?
6.
Or yeah, so this would be n square minus 5n plus 6.
square minus 5 and minus 14.
Hmm?
N square minus 5n minus 14, and then we can solve.
Yeah. So this would be n square minus 5n, 6 minus, so this would be equal to minus 14,
14.
right? Now I have to like, I will do middle term splitting. So it would be n square
Minus 2n minus 7, minus 7, plus 2n minus 7, plus 2n. Man.
okay. So this would be n plus 2 minus 7 n plus 2. So I'm having two values of n, right? So this would be n equals to minus 2 and 7. Now here I won't be considering this negative number. So my value of n would be
7.
7. Everybody got it?
Yes.
The steps are clear to everyone?
Yes, ma'am.
Okay. So this way you will be solving for n. Yeah. So let's say I'm having another n p4 divided by n minus 1 p4 equals to 5 by 3. So the first step is I would be expanding this value. So np4 is written as n factorial divided by n minus 4 factorial, right? Is it fine?
Ma'am.
Okay. Now n minus 1. So this can be written as n minus 1 factorial divided by n minus 5 factorial.
Yes, ma'am.
Okay. Now, I can write this as n factorial. This would go here. So it would be equal to n minus 5 factorial divided by n minus 4 factorial into n minus 1 factorial. I can write this as, is this step clear?
Yes, ma'am.
Yeah. So now, yeah, okay. So which value I would be expanding? Okay, for this to be cancelled, like n factorial and minus 1 factorial. So if I expand this value, I can cancel this value.
Yes, ma'am. You can.
Ma'am, we can common n and then n into n minus 1 factorial. Then.
And if I expand n minus 4, I can, like n minus 5 factorial will get cancelled,
Yes, ma'am. Definitely.
right? So I can write this as,
Minus 5 factorial. Yeah.
right? So here n minus 1 get cancelled, n minus 5 get cancelled. So in total, I have n upon n minus 4 equals to 5. So now if you do cross multiply, it would be 3n equals to 5n minus 20, right? So this would be equal to 2n equals to 20. So n is equals to 10. Is this thing clear?
Yes, ma'am.
Everyone?
Yes, ma'am.
Now the last thing is we are solving for r. Okay. So if my value is, my expression is 5 p.
Ma'am, your voice is not clear.
Yes, ma'am.
Now is it clear?
No,
No,
ma'am.
ma'am.
I guess a microphone issue.
Hello.
No, ma'am. Suddenly your voice level dropped.
Is
Volume.
it great? Volume is great. Is it clear now?
Yes, ma'am.
Yes.
Okay. So I have to solve for r. So it would be 5 PR. Okay. So my expression is 5 PR equals 2 into 6 PR minus 1. Okay. So first of all, I would be expanding this value. It would be 5 factorial divided by 5 minus r factorial. Similarly, 2 into 6 factorial divided by 6 minus r plus 1 factorial.
Yes, ma'am.
This step is clear to everyone?
Yes, ma'am.
Okay. So now, so basically this would be 5 factorial divided by 5 minus r factorial, 2 into 6 factorial, 7 minus r factorial. Now, if I expand this value, it can be written as 6 into 5 factorial,
Yes, ma'am.
right? And if I expand this value, this would be 7 minus r into 6 minus r into 5 minus r factorial. See,
Yes, ma'am.
right? See, this is 7 minus r minus 1. Like 7, it would can be written as 7 minus r into 7 minus r minus 1, right? Factorial. So this would be equal to 7 minus r into 7 minus 1 is 6. So it would be 6 minus r factorial.
Yes, ma'am. Got it.
Got it? Okay. Now if you see here, 5 factorial would get cancelled. 5 minus r factorial would get cancelled. So the remaining value would be 2 into 6 divided by 7 minus r into 6 minus r, which is equals to 1.
Yes, ma'am.
right? So if you solve this, you will get the value of R as, so if you solve this, you will be getting two values, 10 and 3. Okay. So tell me which value I would be considering.
3.
Why?
Because R should be less than or equal to n.
And the value of n here is?
Uh, remember, I forgot because in the question, I have to see the question. Yeah. 6.
Yeah, 6 or 5. Yeah. So here the value of R should be less than 6 or 5. So it is 3 only. Okay.
Yeah, ma'am.
Yeah. So this was the last thing. So anybody having any doubts?
Ma'am, in
we-
second step,
Second.
this 2 into 6 factorial divided by 6 minus r plus 1.
Yeah.
R plus 1.
3. So this is basically n minus r factorial, correct? Here n is 6 minus what is my r? R minus 1.
Okay.
Yeah, so this would be written as 6 minus r plus 1.
Okay, ma'am. Got it.
So anybody having any doubts in this whole lecture?
No, ma'am.
Sure.
If this concept is over, then ma'am, let's that NP0.
Yeah. Okay. Just give me a few minutes, okay? I will just think about one.
Ma'am, I have a dot in some activity question and weekly tutorial.
You have doubts from that?
Activity questions and weekly tutorial.
Okay. Okay. Like if you're having any doubts in that, you can ask on Tuesday. We have doubt session, right? Like let me just complete this thing, then uh, we'll get back to the activity question. Is it fine? Is it fine, Alok? Who asked?
Sorry, ma'am.
Yeah, who is having doubts in activity question?
I have, ma'am.
Yeah, so let me just complete this down, then we will get back to that.
I posted the question in chat box.
Okay. So basically, okay, in this, it is saying that n objects Um, so let's say, for example, I have like A, B, and C, right? So the possible ways, if I take all at a time, so it would be 3P3, right? So there are in total how many ways I can arrange this? It would be 3 factorials, right? So if I'm
Yes,
taking
ma'am.
2 at a time, it would be 3P2, right?
Yes,
So
ma'am.
yeah, so this would be equal to 3 ways, right? Then if I'm taking 1 at a time, so it would be 3P1, which is equals to 3 ways.
Yes, ma'am.
Okay. Now I'm taking 3P0. That means that we are not arranging it. Okay. That is like there are 0 objects to arrange.
Okay.
3P0 in the sense we can say that like there is one, like the one thing that we can do, that we are not like we are doing empty arrangement, as if like there is no arrangement, but so that like there is only one possibility, right? Like there is one way of doing, like arranging nothing, we can say in that way, like we are not arranging anything. So there is only one way of not arranging anything, it would be equal to 1 only, like
Maybe.
that.
Yes.
Yeah.
Okay, ma'am.
So in that way, it is like NP0 if we are arranging 0 objects from the n distinct objects. So it is equals to 1. So there is only one possibility, that is we are doing nothing, right? Like in sense, we can say that. Here we have like 3P1. That means we are arranging one object from the 3 objects. So there are 3 ways I can do it. 3P2 is like we are arranging 2 objects from the 3 distinct objects. So there are 6 ways I can do that. So similarly, 3P0, that I am arranging 0 objects. That is, there are no elements for arrangement. But in the sense we are arranging nothing. That means there is only one way that we can't arrange anything. We can say like that. Got it?
Yes, ma'am.
Yeah. Okay. And there was one another, right? Which was it? Okay, this one, right? This one, I'll clear it in the next session, actually. I need time to think about it. Okay?
Okay, ma'am.
Yeah. Okay. So,
Thank you.
okay. Thank you so much. Now, okay. So activity questions, you're having doubts in activity questions. So the first person somebody asked me about the activity questions, I guess.
Activity question 5.3.
5.3.
5.2 also.
Okay. Five point two, which question?
Second question, ma'am.
The value of expression n minus 2 factorial. Okay, you're not able to solve this?
Ma'am, at that point in time when your class, I didn't attend your class then.
Okay,
Maybe
just
now I can.
yeah, just try it. And also the solutions are there, like activity solutions are there. So you can see the videos and all. Okay.
Okay, ma'am, let me go through once, then I'll
Yeah.
ask you in next session.
Yeah, just go through once. Okay, so everyone go through once the whole theory and all. Okay, then solve the questions. And if you're like, if you're not able to do it, you have the like solution are given, right? You have the
Right,
solution,
ma'am.
you have the activity question solutions, you have everything, practice assignment solutions and all. So you can go through it, then you can ask the doubt. If you're having any doubt, you can ask. Okay, so the next session is like doubt session, right? So you can ask at that time.
Okay, ma'am.
Yeah. And also watch the solve with us. That will help you to solve the graded assignment. Everybody watches solve with us?
Ma'am, in week for week 4, I have no, the content is not showing in my dashboard.
Okay, it's not showing. Okay, fine.
Not no.
Okay, let's see. Okay then. So other than this, Anybody having any doubts?
Activity question 5.3.
Activity question 5.3.
Yeah, 3 number question.
In how many ways can 4 non-identical rings be worn on 5 fingers? Okay. So let's say you have 4 rings, right? 1, 2, 3, and 4. Okay. And you have 5 fingers. 1, 2, 3, 4, 5. Correct? Now, for the first ring, I have 5 choices. Correct?
Ma'am.
For the first ring, I have 5 choices of fingers, right? So the first ring can be put on the first finger, second, third, fourth, or fifth, any of the 5 fingers, right?
Okay.
Right. So I'm having 5 choices here. Now the first ring is gone. Like I have chosen out of 5, I have chosen 1 ring. Sorry, 1 finger. So for the second ring, I am having 4 choices,
Yes, ma'am.
right? So 5 into 4 into 3 into 2.
Yes, ma'am.
Got my point?
Yes, ma'am. Got it.
Got it? Or else you can, let's say, for the first finger, I'm having 4 choices of rings, right? For the second finger, I am having 3 rings. For the third, I am having 2 rings. And for the fourth, I am having 1 ring, right? And for the fifth, like it's empty, let's suppose. Okay. So this way I can have 5 more arrangements, right? So let's say my first finger is empty. The last 4 is filled, right? Or I can say that my second finger is empty and the rest of them are filled. Okay. So this way I would be having 5 cases. Okay. And I can write this as, so it would be equal to 5 into 4 into 3 into 2 into 1. Getting my point?
Yes, ma'am.
Right? So basically this is equal to 5 factorial, which is equals to 120. Got my point?
Yes, ma'am. Yes, ma'am. Question number 4 also, ma'am.
Question number
4.
4. Okay. Oh, this is a big question. Actually, you just watch the solution video. Then if you're having doubt, then you can ask. Okay.
Ma'am, I have done all the activity question, but I have not in this type of in the two question only. So I'm asking.
Yeah, that's what I'm saying, that just watch the video. Like we have uploaded the solution. So just watch it. Then you can ask again. Fine.
Okay, ma'am, I have a dot in weekly tutorial video.
Weekly tutorial. Which one? What's your doubt in that?
Tutorial 5 and 1 also.
It's a video, right?
Yes, ma'am. But I am not able to understand.
Okay, actually, I'm not seeing the videos of tutorial, so I'm not aware of the content what they have done. So let's discuss this tutorial part in the next session. Can we? So you have hanged out in tutorial 1 and 5, right?
Yes, ma'am.
Yeah, I will see and then we will discuss. Okay, the next session.
Sure, ma'am.
Yeah. Okay. Other than this, anyone?
Ma'am, is there any platform to practice questions?
Just do the activities and the practice assignment graded. That's more than enough.
Okay, ma'am. Okay.
Yeah. So everybody understood today's session? It was fine?
Yes, ma'am. Yes, ma'am.
Okay. So once again, you just go through the topic, go through week 5, the content and all, and try to solve it. And if you're not able to solve it, there are solutions. Watch that. Then, if you're not able to solve it, then you can ask. Okay?
Sure,
Okay,
ma'am.
ma'am.
Yeah. Fine. Okay then. So shall we end this meet?
Sure, ma'am.
Yes, ma'am.
Yeah.
Ma'am, when your next session would be?
Actually, the next doubt session would be taken by Prerna ma'am. So I will tell her what are the doubts that you are having. Like today, the doubts that you have asked, she will clear it on the next session. Okay. So I will
Okay,
tell her.
ma'am.
Yeah. So don't worry about that. So yeah. So the next, like the revision session would be taken by me.
Okay, ma'am.
Yeah. Okay then. So yeah, everybody is preparing for the exam.
Yes, ma'am. How should I prepare for the quiz one for foundation? I'm a foundation level of a student actually.
Yeah, the thing is that just go through the whole topic, just go through all the content and all, and do all the practice assignment, activity questions, and graded assignment. Right? And if like there are weak mock test and all, just do that. That would be more than enough. Just don't worry about it. Okay? But you should be clear with the content. Okay? Yeah.
Thank you, ma'am.
Okay. Okay, everyone. Thank you so much.
Thank you, ma'am.
Yeah. Okay. Have a great day.
You too, ma'am.
Thank you. Okay. Bye.